All right, so we're looking at day 2, integration by substitution. And we learned on day 1 to make u the inside, and then our du is the derivative of u, and you pick the right u when you take the derivative. It's already in the problem, except for maybe a constant that you need to put in. If you put a constant in, you multiply by the reciprocal on the outside. So when you have trig, we didn't see any ones yesterday with trig, you're thinking of the same thing. Like, what is the new inside here? So normally when we integrated, our inside was just x, but see how the inside here is 3x? So that's when you say, all right, I'm going to make u the inside of the trig function, which would be 3x. The derivative of 3x is 3dx. All right, to substitute in my du, I need a 3 times dx. I don't have the 3 in there. So I'm going to put a 3 in and compensate and multiply by 1/3 on the outside. And when I do that, I get 1/3 on the outside, the integral of sine of u du. So the u replaces just the 3x, like we said right here. The 3dx that I'm underlining in green is your du. Now you have to remember your integration formulas. So the integral of sine is negative cosine. So the integral of sine u is negative cosine of u plus c. Don't forget you had a 1/3 out in front. And then what you're doing is replacing the u with 3x. All right, so when you have trig, you're trying to make your u the inside of the trig function. So with cosine here, our u would be 2x plus 5. Our du would be 2dx. So I need a 2 in there, so I'm going to put a 2 in. That'll complete my du right here. And if I put a 2 in, I have to compensate and multiply by 1/2 on the outside. So we have 1/2 the integral of cosine of u du. And we know the integral of cosine. We should at least. It's sine u plus c. And what you're going to do is you're going to plug back in for u. So it'd be 1/2 sine of 2x plus 5 plus c. All right, the next one here, we're going to pick our u. All right, we should see that we know how to integrate secant tangent. Our new inside is 4x. So we make u 4x. Du is 4 dx. So I have to put a 4 in. That will complete my du right there. And if I put a 4 in, I have to compensate and multiply by 1/4 on the outside. So that's going to give me 1/4 the integral of secant u tangent u. And if you think backwards, what can I take the derivative of to get secant tangent? And that is just secant. So the integral of secant tangent is secant u plus c. You had these all memorized before. You're supposed to still know these. So I'm going to plug back in for u. And my u is 4x plus c. All right, next one here, cosecant squared 8x. So you should know how to integrate cosecant squared. So our new inside is 8x. We've only seen our inside being x before, so we make u the new inside, which is 8x in this case. Derivative of 8x is 8 dx. So I have to put an 8 in to be able to complete my du, and that means I need to compensate and multiply by 1/8 on the outside. So I'm going to get 1/8 the integral of cosecant squared u du. And the integral of cosecant squared is negative cotangent. So it would be negative 1/8 cotangent of u plus c. And then you plug back in for u. So you get cotangent of 8x plus c. All right. So we're going to look at just two more. For 14, the integral of cosecant cotangent, we know that. So our new inside is x cubed. So you're going to make u x cubed. Now the derivative, or du, derivative of u is 3x squared dx. Now look at this. You know you picked the right u when your du is mostly in there, except for maybe a number. So we already have the x squared dx, right? This x squared dx. We already have that in there. What do I need? I need a 3. So just put it anywhere in the integral, the 3 you need, and just don't forget to multiply by 1/3 on the outside. That gives us 1/3 the integral of this right here, cosecant, this becomes u, cotangent u. So cosecant u, cotangent u, and the 3x squared dx, what I have underlined, is replaced with du. And cosecant cotangent integrates to negative cosecant. So it's negative 1/3 cosecant u plus c. And the last step is to plug back in for u. So it'd be negative 1/3 cosecant of x cubed plus c. And the last and final one for day 2 is 15. The integral of 1 over x squared, secant squared 1 over x. The main thing you see in there is secant squared. You should know how to integrate secant squared. So our new inside is 1 over x. Now, that's also written as x to the negative first. So when we derive this to get our du, that's going to be negative 1 x to the negative second, using our derivative rules. Negative 1 x to the minus 1 to the power, negative second. So when we rewrite that, we get negative 1 over x squared times dx. Well, look at this. 1 over x squared dx is already in the problem. That's how you know you picked the right u. You just need to throw in a negative. And if I throw in a negative on the inside, I'm going to throw in a negative on the outside to compensate. So what I have here is negative the integral of secant squared of u, and the rest of it is du, right? The u replaces the 1 over x. The rest of it is my du. And secant squared integrates to tangent. So negative tangent of u plus c. And you plug your u back in. So negative tangent of 1 over x, that's our u, plus c. All right, so you're supposed to know your integrals are your trig functions. Once you recognize that, you pick u as the inside and go from there. And tomorrow, or the next day, we're going to be looking at more complicated integrals like these.